Welcome back, third grade scientists. Today we're going to talk some more about extreme weather. Today we're going to study lightning and thunder. So let's get going. Well, first of all, ask yourself, what is lightning? Lightning is a bright flash of electricity produced by a thunderstorm. Can you get a picture of lightning in your mind? Have you ever seen it in person? This is a beautiful picture of lightning flashing across the sky. What causes lightning? Well, lightning is an electric current. Within a thundercloud way up in the sky, many small bits of ice or frozen raindrops bump into each other. And as they move around in the air, all of those collisions are creating an electrical charge. After a while, the whole cloud fills up with electrical charges. The positive charges or protons form at the top of the cloud, and the negative charges or electrons form at the bottom of the cloud. Since opposites attract, that causes a positive charge to build up on the ground beneath the cloud. The ground's electrical charge concentrates around anything that sticks up, such as mountains, people, or single trees. The charge coming up from these points eventually connects with a charge reaching down from the clouds, and zap, lightning strikes. Can you hear lightning? Well, lightning and thunder go together. So if you know how to count, you can tell how far you are away from a lightning strike during a thunderstorm. Here's what you're going to do. Step one, the next time there's a thunderstorm, and with the spring and summer months just ahead of us, there will be thunderstorms, find a safe place in your house where you can watch the lightning through a window. When you see the flash of lightning, use a stopwatch and count the seconds between when you see the lightning and hear the thunder. The time between the lightning and the thunder tells you how far away you are from the lightning hit. If you see and hear the thunder at the same time, or really close to the same time without being able to count, yikes, that means the lightning is super close. But for every 5 seconds that you counted, that means the storm is 1 mile away. So for instance, if you count 10 seconds between the lightning and the thunder, that means that storm is about 2 miles away. If you counted 15 seconds, the storm's 3 miles away. Just divide the number of seconds you counted by 5 to see how close or how far away the storm is. Here are some lightning fun facts. Lightning that's more than 15 miles away is too far for you to hear the thunder. So even though you can see this lightning without hearing any thunder, sometimes people call this heat lightning. Lightning is extremely hot. It can reach temperatures of 54,000 degrees Fahrenheit. That's 6 times hotter than the sun. Lightning and thunder actually take place at the same time, but because light travels to your eyes faster than the sound can travel to your ears, you see the bolt of lightning before you hear the rumble of thunder. Lightning appears to be a clear or white or yellowish color, but really it depends on the background of where it's striking. So now let's enter the fun zone. You can actually create your own thunder and even lightning. You don't need lightning to create your thunder, and I'm going to teach you a safe way to create lightning at your home. First, let's work with our thunder. First, you need a brown paper bag. So here you see I have a brown paper bag, similar to like something you would carry your lunch in, a lunch bag. You're going to take the brown bag and you're going to blow into it until it's full of air. When you think you have it blown up with the air inside, you're going to twist the open end closed with your hand. With your empty hand, you're going to smash the air-filled bag and pow, you heard that thunder? The air that rushed out of the bag pushed away the air that was already surrounding the bag, the same way that lightning causes air to expand and push. The air moves forward in a wave, and this wave reaches your ear as sound. You can also create a safe form of lightning at your home. Since you need a very dark space, I can't demonstrate it on this video, but it's a super easy explanation, so I'll explain to you what to do. All you need is a balloon and some kinds of wool clothing or sweater. It could be a piece of yarn or a sweater, and a room that has a metal surface, like perhaps a doorknob. First, you're going to blow up that balloon and tie it off at the end. Then you're going to take the balloon and your piece of wool or sweater into a room like a bathroom or a basement where there's not a lot of light, or where you can close a door and make it nice and dark as you can. Then you're going to rub the balloon against that wool surface or sweater 10 times or more really fast. So you can see that this boy or girl probably did that and now is holding it up to her hair, and you can see that electricity, right, pulling on her hair, because that friction of rubbing the balloon against the wool creates that electrical charge. Once you do that really quickly, move the balloon close to a metal surface and zap. You should see a little bolt of your very own safe version of lightning. Have fun with these experiments with thunder and lightning. You're doing a great job. Keep up the great work. They're great scientists.